So today we're going to continue our study of properties. The distributive property happens so often in math that I'm going to give it its own day. So we're going back to the chart that we started last week. We're going to fill in this last section. I'll give you a minute to get that out. You can pause and then come back. So the distributive property, I have a little note down here, think, give out fairly. And then I have the cards as the picture reminder. So think about this. Close your eyes. Pretend you're in a classroom. Maybe it's mine at school. Maybe it's another teacher's, another subject. Maybe it's one of your favorite elementary school teachers, but you're in a classroom somewhere with lots of kids in the room. And the teacher walks over and hands you a stack of papers and says, please distribute these to the class. Well, what do? You're certainly not going to keep them all because they're worksheets, and I know you don't want to do every single one of them for the whole class. And you're probably not going to give it to just your friends because, everybody's got to share in this work that you have to do. So you're going to go around and you're going to give the same amount to every kid in the class. Maybe it's one paper, maybe it's 3 papers, it depends what you're working on. But every single kid is going to get the exact same amount. That's what happens when we do distributive property. We're distributing, we're giving out a number. Now, there's multiplication, it has to be multiplication, and either addition or subtraction. You'll never see division. All right. The examples that we do usually only have 2 members. If you think of this as the class, there's only 2 members in the class. However, it is possible that you can have multiple numbers. And I can show an example of that at the end. Okay, so this is what it looks like with algebra, with just letters. This is A times the quantity of B plus C. So what we do is we distribute this A and give it to the kid called B, and we distribute this A and give it to the kid called C. Now there's only so much combining I can do because I have just letters here. So my answer for this, or the equivalent expression, would be AB, right? A times B, keep the plus sign, and then AC, A times C. That's it. That's as far as I can go with that particular one. Now, for this example that has just numbers, you'll notice I switched to subtraction. So I'm going to do the same thing. I'm going to give out the 3 and give out the 3 so that each kid in the class gets 3 of whatever it is we're giving out. So this looks like 3 times 7 minus 3 times 5. And from there you can simplify. So this would be 21 minus 15, and then 21 minus 15, final answer of 6. And I know you all just rolled your eyes and went, why do I have to do all that work? Why can't I just do 7 minus 5 and get 2, and then do 2 times 3? It's so much easier. Well, you can, and that might be something that you want to do as a double check, but this is how you would use the distributive property. Okay, now let's go on to some more examples. I have for you 6 examples and maybe a 7th one if I fill one in at the end with more than just the 2 kids in the class. Pay attention because these have both letters and numbers, and there's also negatives, and the negatives are what trip everybody up. Now, in the beginning, I'm going to highly recommend that you draw these arrows, where you put the arrow in the end and you just draw the arc, to remind yourself to give that front number out to everything in the parentheses. Right? So this turns into 8 times negative 9 plus 8 times 4. After a while, you start doing these in your head, and you end up with negative 72 plus 32. And if you remember, these are different signs, so we're going to subtract them. 72 minus 32 is 40. That pile was bigger, so my answer is negative 40. Now, if you want to double check yourself, negative 9 plus 4 is negative 5, and negative 5 times 8 is negative 40. There are situations where you'll see that front number not in the front, but rather at the end. That's the same situation. You would still give this out. Sorry, I was supposed to go to 4. You would still give it out to each one of the numbers, and it shouldn't affect your answer. All right, let's look at number 2, where we have a variable. I'm going to draw my arcs to remind myself. This becomes 4 times x, or just 4x. Keep the plus sign, and then we do 4 times 7. Now, very soon you're going to see me not write this. I'm just going to say, 4 times 7 is 28, and leave my answer as 4x plus 28. That is as simple as I can get it. I cannot combine the 4x and the 28 because this does not have an x. They would be considered unlike terms. All right, going to the next one. Starting to get some subtraction signs going here. So we're going to get 6 times p, keep the subtraction sign, and then 6 times 5 is 30. That's my final answer. All right, now it gets ugly. There's 2 ways you can think of this. You can think of this as -8 as a subtraction sign, or what you guys would say, -8 as a negative sign. I'm going to do it both ways and show you how it works. All right, so first, let's think of this as a subtraction. Okay, so we're going to do the -2 times x, right? 2 times x is 2x. Keep the sign because there's only one sign. I'm going to keep this as a subtraction sign. So now I'm doing -2 times 8, which is -16. So the first subtraction sign was because of the subtraction, and the second subtraction sign, or the negative, was because it was 2 times 8, and there was only one negative sign involved. Now, you know that we can do a 2-stroke, or a change the opposite, which now becomes -2x plus 16. Final answer. I cannot combine those because one has an x and one does not. Now, let's do this problem as if this was a negative sign. I'm still going to get that -2x in the beginning, but now I'm going to do -2 times -8. 2 times 8 is 16. There's 2 signs that go together, so that's a positive, which means this is positive 16. It's the same answer. It's a different way of thinking about it. Okay? If you're really, really comfortable with your negatives, you might be able to do this. If you're not super comfortable with your negatives, this might be the better way to go. All right? It's that flexibility, that mental flexibility to be able to see this as a subtraction sign or to see it as a negative sign in the same problem. All right, here our example has 2 variables. Nothing changes. We're still going to multiply this number out front times the coefficient, that number that's with it. So here, 5 times -3 is -15. Keep the x. Keep the plus. And then 5 times 7 is 21. Keep the y. That's my answer. I cannot combine them because one has an x and one has a y. They're not the same. All right, and then for good measure, the book likes just to throw in some fractions, so we'll do those just because. Same thing. Remember that there's a 1 here, that understood 1 that we put in front of numbers or letters. So 1/3 times 1 is 1/3, and keep the x. In this case, I'm just going to bring that subtraction sign down because there's no other negatives that would possibly change it. Then I'm going to do 1/3 times 6, and I'm actually going to make it be 6/1 so that I can calculate this a little bit easier. All right, this is going to be 1 times 6. Let me put it over here. 1 times 6 is 6. 1 times 3 is 3. What's 6/3? It's 2. That is the simplest answer I could give. Now, if this is 1 over a number, you could take your whole number and divide by the denominator, because that's really what we're doing over here. All right, I have one last example for you. This is your bonus. Let's say that I've got 7 times 3x plus 6y minus 2. In this case, the class has 3 kids, right? 1, 2, 3. We would call them terms. The inside the parentheses has 3 terms. Nothing changes. We just have an extra thing to work with. 7 times 3 is 21. Keep the x. Bring down the plus. 7 times 6 is 42. Keep the y. Bring down the subtraction. There's nothing else to change it, so I can just bring it down. And then 7 times 2 is 14. 3 that we started with, 3 that we're ending with, and that's my final answer. I can't combine them because some of them have an x and some of them have a y, and some of them are just a constant and have nothing. These are kind of fun. There's a couple little things you have to be careful of. Lots of practice, and you will do well with it.